Hey, how you doing? I was asked to talk a little bit about integration by parts. Now, in integration by parts, well, we might ask, what is it? So it's a method used to integrate when there's several functions inside of the integrand. And typically what I'm looking for, if I'm going to use integration by parts, is something in there, one of the functions, is really easy to take integrals of, antiderivatives. And the other one, if I took more and more derivatives of it, it would eventually go away. So those two properties make this setup perfect for integration by parts. So as a reminder of what it does, to get the formula, you could go straight to it if you haven't memorized, which just says the integral of something like this, u prime v would be uv minus the integral of uv prime. That's sort of a notation. That's a little loosey-goosey, right, in that I don't have any dx or dt's written there, but it gets the point across pretty well, I think. If you don't have that formula memorized, it might be helpful to think about the product rule of derivatives, and then integrate this and rearrange algebraically. You'll get the formula up above. Okay, but let's get rid of that for now. So what I would do here is I would notice in my problem that it'd be really great in this integral if the t's went away. The t's go away. So notice in the way I set this up, the v is the one that you would take a derivative of, and the u starts as a u prime, so you're actually going to take an antiderivative. So I'm going to call t squared my v. That way, when I take a v prime, or take a derivative of it, we'll end up with 2t, and the power is being reduced, so that's kind of nice. And I would call u prime, I'm going to say that's my e to the t. And when I take an antiderivative, it stays e to the t, so that's kind of nice as well. So if I use this formula, this is my, well, I guess I wrote it as vu prime, but that's okay, because multiplication is commutative. So this would be the v times the u, so t squared e to the t minus the integral of e to the t times 2t. So the power has been reduced. So for this particular problem, that's an example of integration by parts, but we may want to go one step further. So let's talk about just that last integral there. E to the t with the 2t. Well, I'm no rookie. I'm going to put the 2 out in front so I don't have to worry about it just at this moment. So let's scroll down just a tad here and say in this case, let's sort of rinse and repeat. I forgot the dt there. So using that same formula you see at the top, if e to the t is my u prime, then e to the t is also my u. And if t is my v, then 1 is equal to v prime. So taking these derivatives. So that would tell me this integral, I do have a 2 out in front, so I will need a 2 out in front of everything here, so that's something to remember. So u times v would be e to the t times t, and subtracting off of that, well, the integral of u times v prime, which is just e to the t dt. But notice this is something that's really nice about this, is that's 2 e to the t minus e to the t, so because I could take that integral, no problem. So putting this together with what we found up above, let's go over here. We can say our original integral, maybe we'll do it in white. So our original integral, which was the integral of e to the t squared, that's equal to t squared e to the t minus, and this next part right here, we just took an integral, or that integral as another integration by parts. And so that gives me minus 2 times e to the tt minus e to the t. So this particular method used integration by parts twice. And so I chose it to illustrate that it's a process that sort of can be continuing on and on. And what you may notice here is that in the end, when everything sort of works out, what ends up happening here is we would have the integral of e to the t here, and then for each next subsequent one, it keeps integrating, but in this case it stays the same. And for each next subsequent one in this pattern, you have t squared, you have 2t, you have the 2, and ostensibly you would have the 0, which is why we stopped. And so the t's are taking these derivatives over and over and disappearing. And then as long as you alternate the signs, your pattern sort of will fall out. So that's kind of a nice thing to sort of recognize. So there is an example of integration by parts. This is used in many other ways, but that's the main use that we've seen so far, at least in these last couple of lessons.